We are starting our probability unit. This unit has the potential to be very, very complicated. I want to be completely honest with you. The rules that we do for this unit are extremely simple. Add, subtract, multiply, divide. That's it. The problem is it is the critical thinking for this unit that makes it very, very difficult, to the point where it is this one unit that keeps a lot of teachers from ever wanting to teach statistics. It's not that it's hard, it's just you have to fully think about what's going on. It's not going to be spelled out for you. And today what we're starting with is chapter 13, which is our probability rules. I've given you guys your flip books for this unit and your outline. I'm trying to do your outline a little bit easier to make you guys understand how many days we're spending on each thing, what we're covering each day, all that jazz. I also want you to take a minute to look at your homework. You'll notice that some of these feel like I've given you a lot more Khan Academy homework this time around. I haven't. What I have realized is I've come to the understanding that if I give you guys their unit quizzes and unit tests, weird stuff gets thrown in there sometimes. I don't know, like the probability density curves that confuse the heck out of everybody. So instead of giving you guys the unit quizzes, I went through and I just picked out the sets of problems. So it works out to be about the same amount of questions. Actually, sometimes around it actually was less to do it this way. But that way you hopefully won't get those weird sets of problems where it's like, Miss Augsburger, what the heck? Okay, they should be all very straightforward, nice and easy to understand. Your quiz for this chapter, if you'd like to write that down, is going to be on Friday, the 25th. So you want to make sure that you have your Khan Academy homework done the night before. All right? Between now and then, we need to get through as much practice as humanly possible. We have today, we have Wednesday to get through all that we can. We need to do as much practice as possible. We're not going to be doing as many videos this unit as we have in the past, simply because the notes are not the complicated thing here. But what I need you to understand is with those flip books, don't just make up definitions and say, this is what I think that is. At the end of each chapter, right before the practice, is a box that contains definitions. Write them down from there. I will not be giving you credit if you're making stuff up or if you're missing the main point. As for this middle section here, these are going to be things that we're actually shading in. All right, so these are going to be colored in. They're just going to be different from each of the different cases. We are not there yet. I did ask you to watch a video. Wasn't too long of one. Just going over the basic probability rules. And hopefully you saw that those probability rules are pretty simple. It's not the rules that are hard. It's understanding the situation. And there is no way possible for me to give you every single different type of situation possible, which is what, again, makes probability difficult. But we have some formal probability rules that are easy to understand. First off, probability of anything occurring has to be between 0 and 1. There are no negative probabilities. If you're doing your calculations and you get a probability of 1.34, you should know I've done something wrong. Does that make sense? Should be a big red flag. You cannot have a probability outside of that range. If we're talking about the sample space, and the sample space is every single outcome possible, if you were to take all of those outcomes together, bless you, then the probability of something happening is 1. Okay, the probability of you getting an A, B, C, D, or F in this class is 1. Those are your only options. There is no E for effort. Okay? Simple rules. If we have the probability of an event occurring, the probability that that event doesn't occur is just 1 minus it. And what this little thingy here says, it says the probability of A is 1 minus the probability that A does not occur. That is called the complement. That little C stands for complement. So we have an event, and then we have not the event. Okay? Now, when we have very specific, nice situations, we can do easy baby probability, which is what today is about. It's the basics. Do you know what the word disjoint means? Disjoint. Any idea? Also known as mutually exclusive. For example, being in my third period AP statistics class and being in third period GE English 12. Those are mutually exclusive events. You cannot do both at the same time. You are not going to be at Battlefield High School in Haymarket, Virginia, while you are in Alaska. At least not while you're alive and whole. And no one's like come at you with a crazy machete moment. I get really dark very quickly. Somebody's thinking it. Okay, you might be able to be in Virginia and Maryland at the same time. You can straddle that border, but you're not going to be able to be in Tokyo and New York at the same time, physically. Easy? Those are mutually exclusive. Those are disjoint events. So if I have two disjoint events, the probability of one or the other occurring is simply going to be add them up. Now, with these notations, you have to understand the way this is written. The word or has the union symbol, and that's what that's called. It's called a union. The probability of A or B, if they are disjoint events, they have absolutely nothing in common, is the probability of A plus the probability of B. If I have independent events, that means the likelihood of one thing occurring is not at all tied to or affected by the probability of the other event occurring. So it's kind of like the idea, the probability that these are always not very fun to come up with examples. In independent things, the probability that you took AP statistics is independent of whether or not you like pizza. Would you agree with me? One has nothing to do with the other. It'd be really weird if whether or not you liked pizza affected whether you took AP statistics. Those are completely unrelated. And when you have two completely unrelated events, the probability of A and B occurring, which is known as the intersection, so you see an open, like a little up cup and a down cup, is probability of A times the probability of B. Disjoint. Disjoint, you have this big collection of choices. You're going to make one choice. Okay? So it's saying if I wanted to choose whether or not, if I were to talk about whether or not you have a cat or a dog. Those are not necessarily disjoint events. Does anybody in here have a cat and a dog? There you go. They can occur at the same time. However, the probability of wearing skis and the probability of wearing high heels, you're not going to be doing both of those at the same time. I mean, I don't know, maybe one person's going to be, there's always somebody in the class that's like, but, what if? Okay? That's what we're talking about. I'm going to wear high heels and skis to school tomorrow just to prove you're wrong. Go for it. It'd be funny. Make sure you stop by and say hi. Okay. So that's what we've got there. Now, if we're looking at that, like we're thinking about that, can these events occur at the exact same time? If events can occur at the exact same time, for example, you're going to go to lunch and you're going to go buy lunch. And you have choices for drinks. You have choices for main course. If those events can occur at the same time, then we're not thinking about disjoint. If they cannot occur at the same time, they are disjoint. They are mutually exclusive. That means if you are in one, you cannot be in the other. If you are in Calc AB, you cannot be at the same time in Algebra 1. Does that make sense? Those are disjoint events. Being in one excludes you from being in the other. It used to be you could not be on a professional sports team and go to the Olympics. They've kind of changed that. Now you've got professional sports players in the Olympics, like soccer and baseball and basketball. Okay? But those used to be mutually exclusive. If things can happen at the same time, then all we're saying is that they are not disjoint. Okay? You choosing to wear tennis shoes and a flannel, those are not disjoint events because they can occur at the same time. The one that's a little bit trickier to answer is independent or not. And I really shouldn't have said dependent or independent because it's this massive, long kind of scale from black to white. There's a lot of gray in the middle. So we basically say independent or not independent. And the way that we start with that is you ask yourselves a couple of different questions. Can these events occur in any order? If they, I don't remember if I said yes or no, if they cannot occur in any order, if they have to occur in a specific direction, if you cannot take Algebra 2 without first taking Algebra 1, those are not independent. They say dependent, we just say there's an association. If they can occur in any order, but one might affect the other, then you've got to think about whether or not that's independent or dependent. For example, a lot of you guys don't understand this, but if you apply to colleges, let's say you're applying to Virginia Tech and UVA, can you apply to them in any order? Yeah. You can apply to Virginia Tech and then UVA, or UVA and then Virginia Tech. That doesn't matter. Is your acceptance to Virginia Tech independent to your acceptance to UVA? Is you getting into Virginia Tech going to affect whether or not you get into UVA? I'm sorry? No. I'm saying the likelihood that it's okay, the likelihood that you get into UVA and the likelihood that you get into Virginia Tech, are those completely independent? They're not. Because it's tied by you. If you are a strong student with killer GPA, awesome SAT scores, and the most glorious essays and personal history available, and you've got a really good chance to get into UVA, you probably have a fairly decent chance to get into Virginia Tech. If instead you were kind of like I showed up to school. Yes! I passed my classes. Yes! I'm applying to Virginia Tech. No. You understand what I'm talking about here? If you get into Harvard versus you get into Stanford, those are both Ivy League schools. The likelihood that you get into one is kind of tied to the likelihood that you get into the other because you're the same student. It's not all of a sudden, it's like, ooh, everybody has a 10% chance to get accepted to this school. You get a 10% chance, and you get a 10% chance, and you get a 10% chance. That's not how it works. Okay? They accept 10% of the applicants, but that's based off of your whole person. So those are not independent events. Okay? And this is very, very important because I can tell you right now, there is going to be a question on your quiz where I'm going to give you an example. I'm going to say, drinking at a party and getting that's not a good example. Because cheating on a test getting an A in that class. And I'm going to ask you, are those two events independent, mutually exclusive, both, or neither? Guess what? No matter what, the answer is never both. You cannot be independent and disjoint or mutually exclusive at the same time. We're going to get more into that, into how that works out, but it is physically impossible to be disjoint and independent at the same time. Okay? Disjoint cannot happen at the same time at all. Independent means the probability of one thing occurring doesn't affect the probability of the other. They're two completely different things. Disjoint is about one option event. I'm going to take one thing from in here, and I'm going to look at what it falls under category-wise. Independent, I'm going to do something, and then I'm going to do another thing. All right. Really, today is going to come down to this whole entire unit. I'm going to spend as little time as possible going over the rules, because the rules are like almost stupidly easy. Hey, you see or, add, and multiply. Probability is between 0 and 1. Done. That's not difficult. What's difficult is understanding what the situation is calling for. Now, for this unit, we're going to be doing a heck of a lot of stuff that's just straight from the textbook. The textbook's got a lot of great problems. And really, for this, it's going to be about how much practice did you do. Because of that, for every single chapter in this unit, I've posted online, I think some of them are in your notes, but entire practice set worksheet problems with their worked out answer keys posted. Because this is all about practice. And some of you are going to whip through this and go, oh, that's so easy, that's so easy, that's so easy. Others are going to go, wait, what? And it's all about how your brain is working. So let's take a look at this first problem here. Go ahead and read this, and we're going to go through what the heck it means we're doing. By the way, if you are ever looking for these problems, you're like, but Ms. Augsburger, I really want this written down. Well, we are in chapter 13. This is problem 1 from the book. Okay? Easy peasy. These questions are asking me to do two things. It's asking me to list the sample space and tell whether you think the events are all equally likely. There are a lot of different ways that you can do this. One of the things that I think you're going to see can be very helpful to these problems is actually going to be making a picture, drawing it out. Okay, you don't have this in your notes. Textbook problems you are not going to have in your notes, okay, because you have them in your textbook. The first thing that this asks you is list the sample space. So I'm going to toss 2 coins. When I toss the first coin, what are my options? Heads or tails. So I toss my first coin, I can get heads or tails. Now I'm going to toss another coin. What are my options there? Heads or tails. So that means this picture can help me determine my sample space. My sample space is going to be heads, 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 tails, tails, heads, tails, tails. Does that make sense? Pretty easy? Okay, at each of these stages, what is the probability of getting heads or tails? It's a what? 0.5. So getting heads and then heads, that's 0.5 times 0.5. Heads and then tails, 0.5 times 0.5. Tails and heads, 0.5 times 0.5. Tails and tails, 0.5 times 0.5. Are all of those events equally likely? Yes. A family has 3 children. Record the number of boys. All right, let's think about the sample space. What am I recording? Number of boys. What's my biggest number of boys? Smallest number of boys? Can I have anything in between? Yeah. You can go anywhere from 0, 1, 2, or 3 boys. That's all I'm recording. Are those all equally likely? Let's think about this. For my first child, what's possible? Boy or girl? Second choice or second child? Boy or girl? Third child? Now, what am I recording? Number of boys. So let's go down to each string. How many boys? 2. 2. 1. 2. 1. 1. 0. Now you are just as likely to get boy, boy, boy as you are to get girl, 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 right? It's all 50-50 everywhere you go. But if we look at these, how many different combinations are possible? 8. 2 choices for the first child, 2 for the second, 2 for the third. 2 times 2 times 2 is 8. How many of those have 3 kids? 1. How many of those have 2 children? How many of those have 1 children? 1 child, 1 boy? And how many of those have no boys? Are all of those outcomes equally likely? No. You've got to pay attention to what it is that you're recording. Are all of your arrangements of boys and girls equally likely? Like who comes first, who comes second, who comes third? Yeah, all of those are equally likely, but not when I'm just talking about how many boys are there. So I want you guys to think real hard. C and D. On your own, talk to each other. See what you get. And when I say talk to each other, trust me guys, you want to be able to argue your points here. Here we go. So for part C, these are my outcomes. So the way that I would write this as my sample space would be heads, tails, heads, tails, tails, heads, or tails, tails, tails. That is my sample space. That's how I would write that out. Now, are they all equally likely? Are you talking about for C? Okay. So what it says is that you're going to flip a coin, and if you get a head, you're going to stop. So I got a head, so I stop. But if I got a tails, I would flip again. If I got heads, I would stop. If I got tails, I would do it one more time. Either until you get a heads or you have 3 tails. Okay? And now when I'm talking about heads, each one of these coin flips is a 50-50 chance. So there's a 50% chance that I can stop after 1. 2, that's a 25%. And then this, these are going to be 1/8. So are they all equally likely? No. That's what I'm talking about when I say draw it out. It makes it a lot easier to understand. For part D, it said roll 2 die. So this was one roll. This was the other roll. Those are all of my outcomes possible. And I'm going to just record which one's bigger. Is it possible to have 1 be the bigger number? Yeah. How would you be able to say, I'm going to roll 2 die and my answer is going to be 1? You get snake eyes. So recording the larger number, I could have 1, 2, 3, 4, 5, or 6. But are they all equally likely? There's only one case right there where 1 is going to be the larger number. That's if they're exactly the same. But look at all of these different ways to have 6 be the larger number. Basically, you roll a 6, anything else, 6 is the larger number. So here's how drawing pictures can be very, very helpful. Okay, so that is my sample space. No, they are not equally likely. The big thing that I want you to see here is that just because you can draw a sample space doesn't mean that this chance and this chance and this chance are all going to be the exact same. They rarely are. Okay, all of your outcomes do not have to be equally likely. All right, let's do some problems that are not numbers. Let's just do think about it problems. All right, ton of different cases with this. So what do you think? Have you ever heard anybody say that? Something like that? We're due for some snow. We're due for some rain. Oh, we've had a really dry summer. It's going to be a really wet winter. You've heard that before, right? Do you know what it is that they're trying to say with that? Why do they think they can do that? Okay, so they're basically saying that it's got to balance out, right? And what they're looking at it as, they're saying, okay, well, over the course of a year, it's got to balance out. Is that true? No. It is not going to say, hey, we've had a hot summer, we're going to have a cold winter. We actually had a pretty good summer with rain, that means we're going to have a dry winter. Does not work with that. What is it that they're trying to play upon? For those of you that watched my video. Law of averages. The law of averages does not work in the short run. Law of averages only works, like if you're looking for ever, and even then, it's only if you know for a fact that things are independent and perfectly equal in probability. Yeah, if I'm going to flip a coin 100 times, I would expect 50-50. But does that mean that if I've flipped 50 coins and they were all heads, that the next 50 are all going to be tails? No. I think that's pretty interesting situation that you're working under, that you got 50 heads in a row. But it's not saying that, that means that the next ones have to level it out. There's no such thing as law of averages. We're not going to say that each day is independent of each other. It rained yesterday. That's going to affect the chance of it raining today. What the weather pattern is, it's a pattern. You don't get to just say, we're going to flip a coin and see what the weather's going to be like today. It feels like that sometimes. When you're looking out west and the weather goes from like 84 degrees one day to what I think was like 10 degrees the next, and they got like 3 feet of snow. Yeah, where was that? Was that Minnesota? Not Minnesota, Montana? Colorado? Something like that happened. It was what? Colorado? Happened this year. That was crazy. literally a 70-degree swing from one day to the next. It does not happen very often. Our days are not 100% independent of each other. Okay? What about this? Who is willing to take me up on this? I'll give you $1,500 a year as long as you pay for any accidents I might have. Now, I've been really good. I've been driving since I was 16. I think I've had to rely on, at one point in time when I had to rely on insurance. And the only other times have been the other person's fault. So, since I was 16, one accident. Who wants to take me up on that? I'll give you $1,500 a year to pay for my accidents. You'll do it? You're like, I'll do it. I'll take that risk. Why do you think that's not a very good idea? That one year I did get in an accident. Not only did I total my car, I totaled somebody else's car. And they had to be helicoptered out. It was a very bad accident. They blamed me because I was the one changing, but I was changing lanes. The other person saw, because I had my turn signal on, didn't want me to change lanes, so they hit the gas and sped up. And we clipped, and we both spun, and they did a nosedive and a roll, and that was thank you, insurance. It was the only accident I've been in that was my fault because I was changing lanes, even though the other person was the idiot. So if that was the year that you were dealing with me, you just went broke. Why can an insurance company do that? They collect from a lot of people. And do all of those people have accidents? No, they're betting. And that's what it is. It's a betting game. They're betting on the fact that you are not going to require a payout. So that means that if I'm insuring thousands of people, and let's say 2% of them get in accidents that I have to pay out, then I'll still come out ahead. Because they're, again, looking at the long run. They're looking at the big game here. So you should not accept, hey, just you and me, we'll be each other's insurance providers. I'll give you $1,500, you give me $1,500, we're good. Not a good idea. Because you're making a bet, and that's not really worth the risk. And what we're going to be doing eventually is we're going to be talking about expected values. How much do you think you should make? What's the standard deviation of these? How does it break down? Insurance companies cover a whole bunch of people. The more people you have, the bigger the insurance company. Nationwide is on your side. Progressive. Flow. All of those. Mayhem. Who's the Mayhem one? Allstate. Allstate is Mayhem. And then you have Geico. State Farm. What's the one where it's the General? Go online. Go to the General and save some time. Yeah. The bigger these companies are, the lower the rates they're able to offer you because they're playing the game over a much broader scale. Some of those companies, like the General, they'll actually charge you an arm and a leg because they're going with people that can't get their insurance from someplace else. But if you're going with Nationwide, if you're going with Progressive, with some of those bigger companies, you don't have to pay as much because they're spreading this out, spreading the love. All right. Well, here's some basic questions. Ella. If you can't stay awake, stand in the back of the room. These problems, it's necessary that you understand not just what the answer is, because these would probably be pretty simple, but also what do I expect to see work-wise. So, simple question. 5 blue shirts, 3 red shirts, 2 black shirts. What's the probability of getting a red shirt? Oh my gosh, did your head just explode? That was supposed to be sarcasm. That was supposed to be easy. This is what I'm saying. These general probability rules are supposed to be very simple. They're going to get complicated pretty quick. The way that you would have written this is the probability of red. There are 3 out of the 10. If you chose to write that as a decimal, that's fine. Only if you gave me the fraction first. You must give the fraction. You don't give the fraction, you don't get the credit. Now, there's a lot of different ways to write B. You could say probability of black complement means not black. You could say 1 minus the probability of black. Either one of those are both okay. Either one of those are going to give you the same answer. What is the probability that a selected shirt is not black? 8 out of 10. Please don't bother simplifying. If you do simplify, you actually have to give that first. So don't do it. Don't simplify. Okay. And now I'm going to blow your minds. Pretty sure it's the next one. Just go through and read this problem for me. Do you understand the situation? We're talking about landlines. People either have them or they don't. I like to start by clearly stating everything that I know. So for this, I should know that 25%, what does that represent? No landline. So the probability of not having a landline, let's just do 1 L. We don't need to do 2 L's. Probability of not having a landline is 0.25. What is the probability of having a landline? 0.75. Now, when we're looking at this one, what's the probability that all 5 of them have a landline? That means the probability that the first person has a landline, the second, the third, the fourth, the fifth. All of those 5 have landlines. What does this symbol mean? And. In order to use the rules that I have for and right now, what do I need? Independent. Does your ability to have a landline affect her ability to have a landline? Not really. Right? You should be independent. Okay? And because they're independent, that means, what's the probability of a landline? Means I should be able to do 0.75 times 0.75. 1, 2, 3, 4, 5. Is there an easier way of doing that? Dear Lord, yes. What is it? 0.75 to the 5th, not root 5. It's okay. So go ahead and calculate that. Come on, ladies and gentlemen, calculate that for me. And I want you to take it out to how many decimals? One more time. 4. What do you get? Should be 0. I was like, sometimes this is an easy way of drawing it out because you can physically see. You could also say probability of 5 with a landline. But I've got to be able to tell kind of what's going on. It is B and C that make this extremely difficult. Please read what B says. Okay? What we're thinking about here is I have 5 people. 1, 2, 3, 4, 5. Each of those people either have a landline or not. And for all of them, probability of having a landline was 0.75 versus 0.25. Okay, I'm going a little bit crazy here with trying to explain this. Do I expect you to do this? No. The question said, what is the probability that at least one of them does not have a landline? That means maybe this person doesn't have one, maybe this one, or this one, or this one. But it's not just one of them, it says at least. So maybe these two don't have a landline, or these two, or these two, or these two, or maybe it's these two, or 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 these two. So that's 2 people not having it. Then there's 3 people not having it, and then there's 4 people not having it, and then there's all 5 not having it. Do you see how there's a lot of different ways to arrange that? That's a heck of a lot of work. So to try to figure out the probability of, it said, at least one without a landline. I can either find all of those combinations, which is a pain in the tuchus. And I could say, all right, I could have 0, 1, 2, 3, 4, or 5 people. If at least one of them does not have a landline, then that means that can either say no people have a landline, 1 person, 2 people, 3 people, 4 people, or 5 people doesn't count, right? Because if I had 5 people with landlines, that would break this rule. Do you understand? There's only one situation that would break this rule. There are a whole bunch of situations that wouldn't. When you see an at least problem, at least, always do 1 minus the probability of the opposite. So that means if this says, what is the probability that at least one of them does not have a landline? I'm going to do 1 minus the probability. At least one does not have a landline. What's the opposite of not having a landline? Having a landline. So I'm going to do 1 minus the probability of all have landlines. You see what I'm talking about there? So I'm going to be doing 1 minus the probability that all have a landline. What's the probability of having a landline? 0.75. Having the landline is 0.75. How many are there? All of them? 5. So calculate that for me. How many decimals? What do you get? Don't want to be sleeping through this, guys. This right here is one of the hardest concepts of the entire year. I am not kidding. Okay, what is the probability that at least one? You see that phrase? You see that phrase? At least one. What should you do? 1 minus what? Probability of the opposite. At least one of them has a landline. So what's the opposite? None have a landline. So that means 1 minus, what's the probability of not having a landline? How many of them is that? Calculate that. This idea of at least and at most are going to be the hardest thing that we do all year long, and we're going to do a lot of it. What do you get? Okay? If you're not understanding that, that's okay. You can get by with just remembering, if I say at least 1, you do 1 minus the opposite for all of them. And then you'll be fine. Okay, some of these problems are going to be redonkulously easy. Read through this question for me. By the way, this is not a multiple choice question. You have A, B, C, D, E. Each of them are a yes or a no question. Is A possible? Okay, A is possible. B? B's good. What's wrong with C? It's greater than 1. 0.2, 0.3, 0.4, 0.5. Well, that's 1.4. Okay, it's going back to your rules. All of your probabilities have to be between 0 and 1, and the probability of all of them have to add up to 1. That's fine. It just means that green's the only option. 1. You cannot have a negative probability. And you cannot have greater than 1. So we're breaking a couple of laws there. Do you see how quick and easy that is? You're just basically saying they've got to add up to 1. Okay, read this one. Some of these are simple. They're just think about it problems. There's a lot of thought that goes into this class. And in order to think, you've got to first be awake. Yeah? Nope. Nope. Say it again. They are not disjoint events. What do you mean by saying they're not disjoint? You can have both at the same time. How many of you, your family, has both a computer and an HGTV? HGTV? That's better. HDTV. Well, it just so happens that almost every single TV out there right now is HDTV. And I watch HGTV on my HDTV. Big fan of HGTV. Home and Garden Television. Oh, yes. House Hunters International, that's the best. What are they trying to do? They're just trying to add. They're trying to say 46 plus 18 is 64. It's a very simple mistake, but a lot of people would look at that and say, yup, 46, 18, 64, sounds good. Because you don't actually think of the problem. But you can only use that addition rule the way that we did if the events are disjoint. Additional rule doesn't work. So grab your notes. We're going to do some problems from your notes. Says practice quiz. I just forgot to change the title of that. That just means, hey, guess what? This will look very similar to what your quiz will look like. Ah, gasp and awe. So I want you guys to try number 1. Work together. Work it out. It's not the easiest thing in the world. Just going to look at number 1, and then we'll work through the others. So I kind of want you guys to see how I work these out. Here we go. So the first thing that I do when I do these problems is I list out my main probabilities. So the probability of getting one question correct, which is very hard to see, is 1/4. Random monkey intelligence, anybody just randomly picking the right answer, versus the probability of getting it incorrect is 3/4. Any one question. So in order to get none of the questions correct, that means the first, second, third, fourth, and fifth problems. 1, 2, 3, 4. I need another one. are all going to have to be incorrect. So that's 3/4 to the 5th, or 0.2373. All of them right. Correct. Yep. 1/4 to the 5th. And I wrote this out just to make sure you guys understood, hey, that rounds to this. And then when we talk about at least, if I say at least one wrong, that means I'm going to do 1 minus the probability that they're all the opposite. So 1 minus the probability that they're all correct. And for D, in order for this to occur, I'd have to have correct. So the first 3 right, the 4th one incorrect. I don't care what happens on the 5th one, so I'm not even worried about it. Questions on that situation? Yes. Go over D. Well, it says you get your first incorrect answer on the 4th question. That means the first 3 were all right. So that means I have correct. Then I got it wrong. So that each of those corrects are 1/4. The incorrect is 3/4. If you were to spread it out, that's perfectly fine also. Okay? All right, awesome. Does that help, or you want to see my handwriting? I want to see your handwriting. Okay, go ahead and work out number 2. I see you still confused look. I'm not seeing things. I know this to be true. Caitlin, what was your... That would be a problem. All right, we're going to take a look at some of these answers. So, what is the probability that something is green? Don't give me 2/10. Don't make me think too hard. 0.2. Be lazy. 0.2. 2/10. Yes. No. It's basically, I do fractions if I say like 1 out of whatever, but when they give it to you in percentage form, you can just keep with it. What about the probability it's a primary color? Just in case you didn't know, that meant red, yellow, or blue. I thought you said, huh. 0.5. Not orange. 0.8. And so for my work, I just basically did that. I said, okay, 0.2, 0.5, 0.8. For the rest of them, I like to be a little bit more clear with what I'm talking about. So all blue means blue. So it's 0.2 to the 4th, or 0.0016. Not green should be nice also, 0.4096. At least 1. Always do 1 minus all of the opposite. So at least 1 red would be 1 minus the probability that none of them are red. And the probability of the first one, the 4th one is the first one that's brown. That means not brown. And for C, the big thing you're going for here is that your colors are independent. You are not going to open up a bag of M&Ms and say, okay, I haven't pulled out any reds yet. That means that if I only have 2 left, one of those has got to be a red. I've had bags where I'm missing a color. It's happened. This is only talking about probabilities over the extremely long run. There is no such thing as a law of averages. How are we doing with these so far? Some of you are going, "Brrr." Some of you are thumbs up in. I like the thumbs up. Some of you are still asleep. Okay. All right. We did those already. Okay. Go ahead and read through that problem. This is not in your notes. This is a textbook problem. Textbook problems I did not print out for you. If you want those, they're in the textbook. In order to answer 23, I need to know, can I have a car that needs to be repaired once and twice? If that was the case, what would you call it? If I had a car that needed to be repaired in October and then it needed to be repaired again in November, how would you classify that? Unreliable, okay. But that means that car needed to be repaired twice. So when we're looking at this 1 year period, once, twice, 3 or more repairs, those choices, those are disjoint choices. You're not going to fall in multiple categories. If you need to be repaired 3 times, you don't consider that being repaired once and twice and 3 times. It's just 3 times. So I have once, twice, 3 or more. How can I figure out no repairs? Add the ones together. What would you get? 28. So then the probability of no repairs would be what? Should be 1 minus, so the 0.72. So basically all I would do is I would say, okay, you could even make a table of this if you'd like. All sorts of different ways that you can display this. You can say repairs, and you can say probability. So we have 1, 2, 3 plus, but there's also that idea of 0. So this is 0.17, this is 0.7, and this is 0.4. That leaves me what for there? We already said it. 0.72. If it says need no more than 1 repair, then that means I'm looking at the probability of how many repairs? No more than 1. What fits that requirement? 0 and 1. No more than 1 means I'm only looking at those. So when you add those together, what do you get? 0.89. Some repairs. What am I looking at for some repairs? All but 0. So I'm going to say 1 minus the probability of 0. What do you get? 0.28. I don't care if you put the 0 in front of the decimal or not. Yes, ma'am. Thank you. Good catch. Okay. Now we're going to squish this up a little bit. This is just easier to read when I put it up here for you guys. Give that a shot. Come on. Work together. You're more than welcome to. How are we doing? Easy? All right, let's take a look at my answers. That is not where my answers are going to be. This is where my answers are going to be. Here we go. Is that what you got? Any questions? At least one. Whenever they say at least, you're always going to do 1 minus the opposite. So at least 1 would be 1 minus none. The opposite of having a repair would be not having a repair. So and I did that for both of them. 1 minus the first answer. Now, for 27, we kind of made some assumptions in order to get 25 done. Tell me what I had to assume in order to work those rules. Cars are independent. So we had to say that each car, each car was independent. Do you think that's true? That your cars are all independent of each other? No? Yes? People who say no, why? Not everybody has cars from the exact same company. They're in the same driver, the same driveway. Right. If you're not going to keep regular maintenance up on one car, you all of a sudden going to keep regular maintenance up on the other? Probably not. Maybe you have a really nice car and then you have a junker for everything else. Maybe. But that is not a reasonable explanation. Okay, you cannot expect that to be true. Okay. All right, so we're going to come back and we'll go through this one next class. So please understand, again, your quiz will be on Friday. Your Khan Academy homework will be due the night before. There is a lot of practice to do here. We're going to do more practice next class. There's a Chapter 13 practice worksheet, I believe, in your notes. If not in your notes, it is online with an answer key. You may want to do that.